Hi there, today we're gonna examine two-sum algorithm number 1 interview question in context of JavaScript language. Two-sum problem is a must-know technical interview question. Companies like Google, Amazon, Facebook ask to solve it in their interviews. Basically, this coding question is asked everywhere except of companies which do not ask algorithms at all. Two-sum is a basic level problem requiring knowledge of hash tables or hash maps. Of course, you will be able to find this algorithm on Leetcode and Hackerrank. Let's dive into the task. We're given an array of integers and a target integer called nums and target respectively. For the beginning, let's define our output as two integers which add up to a target value. We assume that each input has the only solution and we have to return an array with just two numbers no matter how many matches we can find. Also, we do not care about the order of the numbers in our final output answer. Considering nums input, we are going to get an array with values 3 and 7. As the constraints, we have got a length of an array with possible range from 2 to 10 to the power of 3. Each element of the array may contain a number from -10 to the power of 9 to 10 to the power of 9, and the target value has the same range as the single item of the array. Sometimes interviewers may hide from you important pieces of information to check if you are attentive. In this case, you have to ask additional questions about input, constraints, and required output. It may change the way you are solving the problem. We finally have everything to write a solution of our first example. Now I'm creating a new function with two parameters and eventually we have to call it with our input variables in order to check the result. Well, the first thing you're going to do is to write an initial loop through the given array. So far so good. Now we want to create a variable with the number we need to end up with our target. And here we came to a tricky point of the algorithm. You might want to create a nested loop to find if there is a needed second value. That will solve the problem, but also lead to quadratic time complexity because we have to loop through the whole array for each item of the array. How can we improve the efficiency here? All those thoughts you have to share with the interviewer to show him you understand what you are doing. Here is where we need to apply our knowledge of hash tables, which have all one-time complexity for searching and adding values. There are three ways to use hash table data structure in JavaScript, and those are set, map, and regular object. We will use set for now. Let's define a new variable on the top of our function. The next step is to check if there is a needed value in our storage. Has method has constant time complexity. If our check returns true, we just return our result with two values. Of course, on our first iteration, our storage will be empty and we have to put there some values, else statement will be in charge of that. If we don't find a needed value, we put our current value to our storage with all one-time complexity, since now on each pass we will take a current value and look for a needed value among all the previously stored values. What if we do not have any pairs when the loop is done? Let's return just an empty array. You might be asked to return false, undefined, or null. Finally, we solved the problem with all end time and space complexity. We sacrificed our space complexity by using a hash table to speed up our function. Let's debug our solution to see what's going on there step by step. In the first iteration, our storage is empty. No magic here. Our current value is 2. We need 8 to get 10. We do not have 8 in our storage, and we add 2 to the storage. The second iteration has value 7, and we need to find 3, but we don't yet have 3 there. We have got only 2 in our set. Now we are adding the current value of 7 to our hash table and moving to the next iteration with value 3. Here we need 7 to solve the problem, and our code finds 7 in our storage. Bingo! The function returns an array with 7 and 3 inside of it. My congrats on that. Now you are asked to return all the pairs without duplicates. No panic! It's just a few lines of code to change. First, we must create a new variable on the top to accumulate our pairs, which is a simple array. We will push all the found arrays of numbers to there. Now we have to change the code of the body of the if statement. Instead of returning, we will push to our pairs array. In order to avoid duplicates, we delete from the storage needed value. Why? Did you spot another 7 in the array? If we do not delete 3 from the storage, then it will generate another pair 3 and 7, and it will be a duplicate pair. We are given a task to avoid duplicates. Here you go. We have a solution. Try to debug this solution by yourself in your IDE. And guess what we have to do to return all the pairs, including duplicates, if we are asked. Right, just remove one line of code where we delete value from the storage in case we found a pair. Let's suppose we are given the same task, but now we have to return indexes of pairs instead of numbers. Let's also solve this problem with help of storing complement and its index as the map. Complement is a value that we need to complete the pair. Here is our new function. Instead of set, we are using a map which is built on top of a hash table too. The main difference between set and map is that map stores keys and values, whereas set stores only unique keys. We need a map because we are going to store a complement as a key and ID as a value. We still need pairs array, but we will store indexes of occurrences instead of their values. We have a change to our loop, since now we have to track indices and we loop from 0 to the end index, which is the length of the array minus 1. Denote the length of the array out of the loop as the best practice to gain speed of the algorithm. Inside of the loop, we check if there is our current value in the storage, which is a complement of any of previous values. If there is, we get the value of the complement, which is the ID of the previous item, and add an iteration index, which is the ID of the current item, and return the result. Otherwise, we add the currently calculated complement to the storage with its ID, iteration index. Our second example is beaten, but there is a third major case. We're given the same task, but the input array is sorted. Will the solution be the same? Well, you can do that the same way, but it's not what the interviewer expects to hear. Let's dive into the third function with the sorted array. Here we have a new array nums2 with all the items sorted. If the array is sorted, we are able to solve the problem with 2 pointers that track our start and end indices of the array. First, we create a new start variable with a value of 0. Right after the start variable, we need the end variable with the value of the last index. Then we create a while loop, which iterates until the start doesn't equal the end index. Inside of the loop, we denote a sum variable where we have a result of addition of the start and end values. If the sum is greater than the target value, we decrease our end pointer by 1 because we need a smaller number. If the sum is less than the sum, we increase our start pointer by 1 because we need a bigger final number. Else statement catches the case if the sum equals to our target value, and we return values from the array of the start and end pointers, or just indexes. This solution is better than all the others because it has all one space complexity. We use primitive variables rather than hash table storage, but time complexity remains all of n. Let's have a quick walk through our iterations. On the first pass we have values 1 and 7. The sum is 8 and it's less than the target. We increase our start index by 1 and now our values are 3 and 7. The sum is 10 and we found the answer. We're done with all the possible solutions. Let's discuss possible test cases that you might be asked. What do you want to test? It depends on constraints you have got from the task. Check nums and target params with wrong data type. For example, we got an object instead of an array and string instead of target integer. You might want to add a specific check. Check the array input with mixed integers and strings. If you were not told you had an array of only integers, you would have to consider it in your code by converting all the items to integers. Check if the array is empty or has just one item. Then just add a small check on the top of the function and return an empty array if the check returned true. Check with an input array filled with a mix of negative and positive integers. Test an input array that does not contain any pair ending up with a target value. Test an array with a big number of items, let's suppose 10,000. We have finished with our test cases. Are you ready for the last question? If you are applying as a more experienced developer or engineer, you might be asked a question about input filled with millions of integers. What is the correct answer to speed up calculations? First of all, we need to handle our data in batches. For example, we can make it configurable. The second part has two solutions. We can use the asynchronous nature of V8 engine of Node.js by using promise all. We create an array of jobs with our batches. Once the promise all returns a promise with an array of our results, we return the first sufficient result or merge the results. Sounds good, but this solution is not handled in parallel because Node.js is a single-threaded solution. The second option is to utilize multiprocessing, which will handle our tasks using multiple cores of our machine. This method is going to work on our batches in parallel and speeds up drastically the calculations. I recommend you to learn V8 engine and how it works with libuf. Also read about multiprocessing with child processes using Node.js cluster. Then you will be able to answer the question with flying colors. All the examples of the code you will be able to find on my GitHub. The link is in the description section down below. Hope you enjoyed the video. Do not forget to subscribe to the channel to get the latest reviews of frequently asked algorithms. See you in the next videos. Bye and have a good startup.